Hello friends, welcome back to my channel The Powerful Brains. Today we will learn some important topics of thermodynamics. Let's start quickly. So friends, let's start with the basic definition of thermodynamics. What is thermodynamics? Thermodynamics is a branch of physics that deals with the concept of heat and temperature and the interconversion of heat and other forms of energy. That means we can also say that it is a study of relations between the heat, work, temperature and energy. Thus the laws of thermodynamics describes how the energy in a system changes and whether the system can perform useful work on its surrounding. This is the basic definition of thermodynamics. Now, what is thermal equilibrium? When two systems are in contact with each other and if there is no transfer of heat between them and both have the same temperatures, then the system is said to be in thermal equilibrium. That is, two physical systems are in thermal equilibrium if there is no net flow of energy, thermal energy, that is transfer of heat between them when they are connected by a permeable path of heat. In figure A, the system A and B are two gases separated by a wall, which is a diathermic wall, which is also known as conducting wall, which does allow the flow of heat from one to another. Now, in another system, figure B, we have A and B separated by a wall. This is adiabatic wall or insulating wall also we can call. This is separated by adiabatic wall, which is also known as insulating wall. This wall does not allow flow of heat from one to another system. This is two important concepts in thermal equilibrium, that is diathermic wall and adiabatic wall. Now we'll go on next subtopic, that is zeroth law of thermodynamics. What is the definition of zeroth law of thermodynamics? Now it states that two systems in thermal equilibrium with the third system separately are in thermal equilibrium with each other. That means two systems are in thermal equilibrium with a third system separately. Then they all are in thermal equilibrium with each other. For example, in figure A, if we see system A and B are separated by an adiabatic wall. Adiabatic wall, that is insulated wall. These two systems are contact with system C via a conducting wall. This wall is conducting wall and this wall is adiabatic wall or insulating wall. Adiabatic wall and insulating wall. Now the state of the system will change until both A and B become to equilibrium with C. After this is achieved, suppose that the adiabatic wall B between A and B is replaced by diathermic wall. Now in figure B, This wall is replaced. Before it was an adiabatic wall, it is replaced by a conducting wall, that is conducting wall. It is also known as diathermic wall. Now this wall will be insulating wall. So now after this, it is found that the state A and B will not go any further change. That is, both are in thermal equilibrium with each other. This observation forms the basic law of thermodynamics, that is, when two systems are in thermal equilibrium with third system, separately are in thermal equilibrium with each other. This is nothing but the zeroth law of thermodynamics. Now, we'll solve some numericals on this. We have the problem given here. A geyser heats water flowing at the rate of 3 liters per minute from 27 degrees Celsius to 77 degrees Celsius. If the geyser operates on a gas burner, what is the rate of consumption of the fuel? We have to find the rate of consumption of the fuel in this problem. We have given the temperatures, initial and final temperatures, flow rate of water, and heat of combustion of the fuel is also given, 4.0 into 10 to the power 4 joules per gram. Now, volume of water will be, that is heated by a geyser, is 3 liters per minute. Now, mass of water heated equals to 3000. Now, what is the change in temperatures, that is delta T, or increase in temperature, because we are heating it, increase in temperature, that is delta T will be 77 minus 27, 77 degree minus 27 degree, that will give you 50 degree Celsius. This is your increase in temperature. Now, specific heat of water C will be 4.2 into 4.2 joules per gram per degree Celsius. Okay, so we have C also. What is C here? 4.2 joules per gram per degree Celsius. This is specific heat of water. Now, amount of heat used. We have to calculate first amount of heat used. Amount of heat used will be Q equals to mc delta T. Q is heat supplied, so amount of heat used. So Q will be equals to M. What is M? 3000 into C, specific heat 4.2 into delta T 50 degree, that gives you 63 into, if you calculate this, it will be 63 into 10 to the power 4 joules per minute. It is your Q. Now rate of consumption of fuel will be equals to how much? What will be the formula for it? Amount of heat used by heat of combustion. The value of heat of combustion of the fuel is already given to us, so we'll put the values. It will be 63 into 10 to the power 4 divided by, it will be 4.0 into 10 to the power 4 equals to, if you solve this, 15.75. This is your rate of consumption of fuel. First you have to solve the value of amount of heat used, then rate of consumption of fuel by, which is given by amount of heat used by heat of combustion. Now, thank you so much for watching my video. See you next time. Stay safe, work hard.